Hello, in this lab we will study about Kubernetes API access control mechanism. So why does we require API access control mechanism? So it is used by Kubernetes whenever a user, means a human user, is required to grant or require access to the Kubernetes resources. So on what principle this Kubernetes will grant access to this user, and what are the steps it will take to authenticate the user or authorize the user or give admission to the user to use the resources present in the Kubernetes. So these are the steps taken by Kubernetes. First, it will authenticate the user. In authentication, it will check if the it is the real user or some malicious person trying to access into the Kubernetes resources. Then it will authorize that user. Means it will check the role if it is allowed to perform what action this user is allowed to perform. Means it can change what resources and it can read or do changes in what type of resources present in the Kubernetes. Next, it will grant admission. That is, it will check the if the requirements are satisfied by the user or not. The request that is made by the user, if it satisfy all the requirement, only then the admission will be provided to the user. So for example, we can take, I want to travel from city A to city B via aeroplane. So what are the process of authenticating me? First, I will be authenticated, means my authentication is done based on my passport. That is, my identity is checked if I am a real citizen of the country from which I am boarding or not, and where I am going. So this all thing will be checked through my passport. So authentication process is done using passport, and then my authorization is done. The authorization means role binding. That is, what type of visa does I have, what type of ticket does I have, does I am a police official or a business class official ticket, does I have a business type of visa, or I'm going to some other country for work purposes or for other purposes. So based on that, my authorization will bind me to a role that this type of ticket will have seat at that counter. So then my authorization took place, and then my admission controller will took place based on my authorization. Means if I have business class seat, then how much volume of luggage can I carry? Based on that, our admission will be controlled. If the luggage is out of, if my luggage or items are out of volume, then I cannot board the aeroplane. Similarly, other things are checked, like the items, if gun is present or other things that are allowed for that role. Means if the role is simple role, then the items that are allowed, that will be checked, and the requirement, if all those requirements are satisfied, only then it will allowed to go further. The same thing, the similar type of thing is done here. First, in authentication, client certificates, passwords, and tokens, all these things are checked. Means, and for service accounts, means the thing that is checked is web token. Means for how many hours it is required to access this service. Means for 1 hour this lab is valid. So after 1 hour, all the pods must be deleted, and it will not be grant access after 1 hour. So all this authentication is checked in first check. Then the role binding is checked if it is a admin role or a user role linked to a group, and then based on that role, the services that it can access will be given to that user. Means it can get or read a particular data present in namespace only, it cannot modify that data. All these things and role binding will be checked in the authorization process, which can be done also through the role binding, which we have seen, role binding access mode. And then after the role binding, admission controller validate and mutate the request. Means if the volume is present, then it must satisfy the requirement that is mentioned, or if someone has not mentioned the volume, means all resource requirements are checked and can also be changed. Means if a resource or request is required to use 10 GB of memory, then that requirement is checked if it fulfill the value set by us or not, or it will be changed. Means some requests come that doesn't mention the resource volume, means resource quota, the CPU usage or the memory usage that will be required to run this request. So by default, a default value will be given to that request. where the things will be not mentioned, like how many CPU uses will be given, how many memory uses will be given. So by default value will be set that this much volume will be given to this request and this much memory will be given to this. Because if we not set any boundary to that request, it will use all the resources present in the Kubernetes. So all these admission controller check this request and validate and also mutate, means make changes if the request doesn't mention that thing that is required for going to the further rounds. So they limit the request, means limit the resource quota and other things, so that more users will not go to a particular request, and other will doesn't access the Kubernetes cluster. So here we get to know about the authentication, authorization, and admission controller in a brief overview that took place in a Kubernetes. So one thing to note here that if one of the request is accepted in authentication and authorization, it will go to the next step. Means it will check for client certificate. If it get client certificate, then it will pass on to the next step. Or if it get any token, then pass on to this request. Means all of the module need not to be true at the same time. Similarly, in the authorization process, any one of the module can play a role and forward the request to the next step. Means ABC mode can be used for role binding, RBAC mode or web mode can be used for the role binding, means check the role if this user has some role or not. Means one request can authorize the user. Similarly, one request can authenticate the user. But in admission controller, all the requests must be satisfied. Means the CPU usage, the resource quota, the memory usage, all must be satisfied. If one is not satisfied, the request will be rejected. We can see here that the request rejected with the code HTTP code 401 if any of the things will be fulfilled. Means if it get client certificate, then request is fulfilled and pass on to the next step. Similarly, in the next step authorization, if any of the mode is we get any role binding to that user or request, then we pass on to the next state. But here all the modules must be satisfied, means all the requirement must be satisfied, then only it will be granted access to the database. Single request will not be entertained here. Now we get an overview. So in this lab, first we will be getting familiar with the authentication, where we authenticate a user who is requested a web service. So we go to the configuration file and check the user certificate and other details to authenticate the user. Similarly, for service request, we get to know about the requested volume, where we can give tokens for a particular period of time. After that, pod will be deleted. So this is the process of authentication. In the authorization step, we check the authorization of a user, means the action that are allowed to perform on a role, means it can get access or can only read data in a particular namespace or cluster. So here we check the role binding and other things, and what action can a user or a request perform that is linked to a particular role in the role binding cluster. And in the third step, we get to know about the various admission controller like resource quota and limit ranger, which will set the limit of CPU and memory usage in the Kubernetes cluster. So these are the overview of our lab. Now we can quickly go to the steps and see all of this in detail. Now, as we have seen, authentication is the first step in the API control mechanism. So first we get all pods and list all pods that are present in the Kubernetes directory. So here we can also see that a request is will pass authentication if any of the authentication modules successfully authenticate the request, that we have seen that in authorization and authentication, if any of module is request is accepted, then it will pass, while in admission control all the modules must be satisfied. So first we list all the pods and get to know about the configuration file where the all the certificates will be present, and then we see this certificate named Kubernetes Kubernetes admin, which is trying to access our data, which is Kubernetes admin and all the details related to that. Then we can also see all the files present in the configuration and all the commands we can use by using minus help. Then we get all the context and extract the user certificate from the Kubernetes configuration file using this command. So we get the certificate of that user, which is Kubernetes admin, and it is in the group master, which we'll be using in the authorization process also. That is seeing this role binding correspond to the master group. So Kubernetes admin also belong to the master group. So that's why it can change. So here we must note that the Kubernetes admin belong to the master group or system master. Then we try to back up the configuration file before removing the user, as we have get the certificate from the configuration file. So we are trying to do a backup of the configuration file before removing user. So for that purpose we require if we are authenticated for the username, but without a certificate, username and password authentication will fallen back, and the same thing will happen when we enter any random username and password. The request will be forbidden because a certificate is not provided. The same here it is also mentioned, the same result will happen if client certificate is expired or invalid. Then the same forbidden message we can see. Then we come to the service request volume, means when we have to provide access only for a particular period of time, then projected volume will be used. Here we can see that a projected volume will be used, where we will mention for what particular time period we have to provide token to the particular user. So we can view the value of the token by entering this value. So here it has also mentioned that token acquired from the API server will expire after 1 hour by default when the pod is deleted. So pod will be deleted automatically. So authentication will be required for only 1 hour. So then we'll delete the pod that we have created earlier, that is required for the service request purpose only. So we have seen the authentication process in the Kubernetes cluster. So next come to our second step, which is RBAC policy, where we bind role to a particular user. Means we can take a look at what is difference between role and role binding. So role can be considered as a business class in the aeroplane scenario that we have took, that is business class ticket is a role, and role binding means what things it can access, and means where is the what is the quota of the luggage that it can carry and other thing that it can access. And in role binding we bind people, means this type of people is traveling in business class, so we bind people which people are bind to this role. So similar thing take place in this Kubernetes cluster. In role we mention type of role, means admin role, this role or other roles. And in role binding we mention people who belong to this role and the resources that it can access, means this role, the people that are present in this role, the resources that these people can access, and the action that they are allowed to perform. These all things will be mentioning in the role binding. role Role mention what things means what type of role we have created. So here first we see to how can we list all the roles in a namespace. So also before that there is two things to mention: what is role binding and cluster role binding. In role binding we bind a role to a or cluster role to a subject in a namespace, means in a namespace which is virtual subcluster inside a cluster. That role will apply only to that virtual subcluster, means the action that can be performed by a user present in that namespace in cluster. While in cluster role binding, here we mention the action that it can perform in whole of the cluster. So it apply to the whole of the cluster, means a big space, and this role binding apply to only a small area, means action that it can perform on a small area, nodes it can access on a small area, and nodes that it can perform action on the wide area, means key, means whole cluster. So first we see the command to list all the nodes. Then we view the role object for the kube proxy role, means the allowed action on the kube proxy resource. That is only configuration gmap can get access to this kube proxy. No other resource, no other thing in the Kubernetes cluster can get access to the kube proxy. Only configuration maps can get access to the kube proxy. So then we list all the cluster roles, and here we get to know about the cluster admin, and then we look into the cluster admin role, where we see that it is allowed to perform any action, that is it can get any resource and perform any action on that. Verbs means the action it can perform, and the resources mean on which resources, it can perform these actions. So it can perform any action on any resource. Then we get to know who are present in this cluster. Then we describe the cluster role binding, which describe means we have seen cluster role binding tell this role apply to which particular subject. So here we can see that admin cluster admin role apply to the system master, which we have seen in the authentication process also, that cluster admin is trying to authenticate and he is in the system master, so it is checked. Then we confirm if Kubernetes admin is authorized to list nodes. Similarly, we can perform other action. So for that, can I command is used. Can I do this thing? So Kubernetes admin can do anything that we have seen in the role. So here we get a yes response. And if we check any other user like dummy user Tracy, is it allowed to list nodes? So we will get no, because it has no authorization to list nodes. So it will, in this step we will learn about role binding and role binding according to a particular subject and role and what action it can perform. Now here we come to our last part, which is admission controller. So we have seen it has a very much of importance. All of the module must be satisfied for a request to be accepted. Here we can also see none of the module in use reject the request for a request to be allowed. Means all, if any of the module reject the request, then the request will be rejected. So here we can see that there are various type of admission controller like resource quota, which enforce quota configured in a namespace. Means this much of configured namespace will be allotted for the each. And similarly, there is limit ranger to allow for specific default CPU and memory limits for the pods that don't specify any. Means if any pods come without any specification of memory limits, then by default value will be assigned to that pod, so that any overflow will be avoided. Because if no value is assigned to a pod, no memory or CPU usage value will be assigned to a pod, then it can use all the memory and CPU power of a Kubernetes. So that's why a default value will be assigned by the admission controller if no value is specified by them. So here in this step, we first list all of the API server ports and all of the admission controller present in that. So we get to know about various admission controller like default tolerant, second, and various other always deny, always admit, the various type of action that they have to perform. Then we connect to the control plane and list all processes in the machine, and the enable admission plugin that we have enabled means the checks that have to be performed always whenever a request has come. So first, here we have seen that there is a node restriction, which we can see here that node restriction admission controller limit the node and pod object a kubelet can modify. Means a request cannot modify a node or pod, because uh, because if they are modified, the data or resources that are running on that can be altered and can be for security purposes. So that's why here node restriction admission controller we are using. Similarly, we can use other admission controller that are mentioned here. So if we look into this lab, we have seen the various process of Kubernetes API access control mechanism. That is, first it will authenticate the request, then it goes to the authorization, then it goes to the admission controller. So we also take look this by an example and get to know the various things that will occur in the various step. So that's all for this lab, and thank you.